Greetings of the day, dear students. I'm Ifteqar Ahmed, senior faculty at GATE ESE, and I have with me dear Rajkumar sir. He is a senior faculty at GATE ESE. We both teach analog electronics here, and we will together take up this GTQ session on analog electronics. First, I will take up questions on BJT and MOSFET circuits, and after that, Rajkumar sir will take up questions on op-amp and diode circuits.
Thank you, sir.
Yes, sir.
Thank you.
So let me begin with some questions on BJT and MOSFET circuits. These are important areas from where questions come every year in the GATE paper, both electronics batch, electrical batch as well as instrumentation batch. So I will take up here first a question on a MOSFET amplifier. You can quickly go through the question. It is a MOSFET differential amplifier, and we have to solve this MSQ. It is a multiple select question where more than one option can be correct. The options are about calculation of this bias voltage. V bias is a DC voltage for biasing purpose, so we need to find out that V bias, and we have to find out gain also, V0 upon Vi. As you know well from differential amplifier, in a differential amplifier output can be balanced and unbalanced. In the given question, we have unbalanced output which is taken from the drain of M2. Okay, V0 is a unbalanced output here taken from the drain terminal of M2, and we have to find out that gain V0 upon Vi, and we should also find out transconductance for this MOSFETs M1 M2. Now the data given here is some transconductance parameter is given, and drain current of M3 is mentioned as 2 milliampere. Okay, I mean this current is given to us. Let me show it here. This current is given 2 milliampere. We will first of all find out this voltage V bias. To find this V bias, let me indicate here the VGS value. This is VGS of MOSFET M3. We will first calculate this VGS. Now this is a amplifier circuit, so we can consider all MOSFETs in saturation region. Okay, so I will be first calculating here the VGS for M3 by using the saturation current equation. We can apply saturation current formula. IDS equal to mu n CoX upon 2 into W by L into VGS minus VT whole square. I have written here the current equation for MOSFET when it is in saturation region. That current we can substitute 2 milliampere. Current is 2 milliampere, and this parameter is given 1 milliampere per volt square. So 1 divided by 2 into VGS minus VT. VT is a threshold voltage here which is given as 1 volt whole square. Now from here if you rearrange it, it will become VGS minus 1 whole square is equal to 4. Okay, and if you solve it, you will be getting VGS minus 1 is equal to 2, or VGS equal to 3 volt. I have considered here positive root. We actually get plus minus 2 here. That minus 2 we can ignore because VGS cannot be negative here. It is a enhancement MOSFET, N channel enhancement MOSFET, so VGS has to be positive value. So that's the reason I am not considering minus 2 here. I have taken only positive root plus 2, and we got VGS 3 volt. Now once we find VGS, we can easily calculate this V bias. You just have to apply KVL here. If I use KVL, I get V bias is equal to, it will be VGS plus 2 into IDS minus 10. VGS को हमने फाइंड किया है 3 वोल्ट प्लस 2 into current 2K into 2 milli, that kilo into milli it will cancel out, minus 10. Okay, I have applied KVL here. V bias is equal to VGS plus 2 into drain current 2K into 2 milli, that kilo into milli it will cancel out, and minus 10. And from here I get V bias is equal to it will be 7 minus 10 minus 3 volt. So in this way the given circuit has a V bias value minus 3 volt. So we can say option A will be correct here. It is a multiple select question, so let us try other calculations also. We will now find out transconductance for M1 M2. Now this current 2 milliampere, it will divide equally, 1 milli will flow here and 1 milli will flow here. Okay, in a differential amplifier whatever current flows in this branch, that current will divide equally into these two MOSFETs. So I can say M1 M2 they have a drain current how much, 1 milliampere. तो आप वहाँ से ट्रांसकंडक्टेंस फाइंड कर लो फॉर M1 M2, drain current is equal to this 2 milliampere will divide equally, 1 milli will flow here and 1 milli will flow here. Then we will find out transconductance for M1 M2. We know the formula for transconductance in a MOSFET. It is under root 2 mu n COX into W by L into drain current. अब आप यहाँ पर डेटा सब्स्टिट्यूट करिए. This parameter is 1 milli and current is also 1 milli. So it will be like under root 2 into 1 into 1 and we get transconductance 1.414 millimho. So M1 M2 they have a transconductance how much, 1.414 millimho. So option C is also correct here. Then I will find out gain. As I said in the beginning that V0 is a unbalanced output taken from the drain of M2. तो अगर आप gain find करते हैं, let us say this input is V1, this input we can call V2. In the given question V1 is Vi and V2 is 0. Now I will be using the gain formula of a differential amplifier, V0 upon V1 minus V2. Remember it is a unbalanced output taken from drain of M2. So gain will be plus Gm into Rd divided by 2, plus Gm into Rd divided by 2. अब आप यहाँ पर वैल्यूज पुट करिए, इट विल बिकम V0 डिवाइडेड बाई V1 की प्लेस में हम लिख देंगे Vi and V2 we can put as 0. So it is Vi minus 0 in the denominator and that is equal to 1.414 into Rd. That Rd is a 8 kilo ohm resistor here which is acting like a load. So 8K, that milli into kilo it will cancel out, divided by 2. अब आप यहाँ से gain calculate करिए बेटा. It is 8 into 1.414 divided by 2. I am getting a value 5.66 or 5.65. V0 upon Vi equal to 5.66. So in this question option B is also correct. For this MSQ the correct options are A, B and C. Option D will be of course incorrect. So please remember, when you answer a question on differential amplifier, first check whether output is balanced or unbalanced. Here it is a unbalanced output, तो हमने इस तरह का formula use किया है. If you take output from drain of M1, then minus sign will come, minus Gm into Rd by 2. And if output is balanced, balanced output का मतलब होता है कि output taken between drain of M1 and M2. If it is a balanced output, then gain formula will be minus Gm into Rd. I hope everybody understood this question. And let me check some answers here. Yes beta, I have got answers from some of you. Okay, most of you have given the answers A, B, C. Wonderful. I am expecting a question from differential amplifier in the upcoming GATE paper. Okay, so please prepare this topic thoroughly. Let's proceed to the next question. Now this one is a numerical answer type question. It is relatively easy one and we have to calculate here beta of the BJT. We have to find out how much is common emitter current gain beta. First of all, let me show here emitter current. This is a PNP transistor where emitter is shown up. Emitter को यहाँ पर ऊपर की तरफ दिखाया गया है एंड इट इज़ ए PNP ट्रांजिस्टर। तो आप करेंट्स को दिखा दो इस तरह से, दिस इज एमीटर करंट एंड दिस विल बी द बेस करंट फॉर PNP ट्रांजिस्टर, IB फ्लोस आउटवर्ड। तो हम यहाँ पर दिखा देंगे बेस करंट को एंड दिस इज कलेक्टर करंट। नाउ इफ यू ऑब्जर्व that IB comes from here and IC will come from here and those currents will combine and flow into this 1K. तो अगर हम current through 1K लिखते हैं it will be IB plus IC. Okay, I have used KCL here, collector current coming from here and base current is coming through this path, and when you apply KCL, current in this 1K it will be IB plus IC, and we know very well IB plus IC is nothing but emitter current. तो हम इसको सीधे से लिख देंगे इक्वल टू एमीटर करंट। नाउ इन द क्वेश्चन कलेक्टर वोल्टेज इज गिवन 3 वोल्ट। तो हम यहाँ से I को फाइंड कर लेंगे। दिस वोल्टेज इज गिवन 3 वोल्ट। VC का मतलब होता है वोल्टेज बिटवीन कलेक्टर एंड ग्राउंड, इट इज गिवन एज 3 वोल्ट। तो आप I को फाइंड कर लो। I इज इक्वल टू दैट VC डिवाइडेड बाई 1K। 3 वोल्ट divided by 1K, it is 3 milliampere. 3 milliampere. Then you can calculate base current through KVL. You can indicate here voltage VEB, and you can apply KVL in this loop. Just use KVL here. We get 10 is equal to 1 into IE, that emitter current is 3 milliampere, okay, plus VEB plus 100 IB plus 1 into emitter current, that emitter current is 3 milliampere, okay. I have just applied a KVL here. 10 is equal to 1 into emitter current, that emitter current is 3 milliampere plus VEB plus 100 IB and plus 1 into emitter current which is again 3 milliampere. अब आप यहाँ से बेस करंट फाइंड करिए बेटा। IB is equal to it will be 10 minus this is 6 plus 0.7, 6.7 divided by 100. So 10 minus 6.7 it will be 3.3 divided by 100, and this will be in milliampere, okay. Now once we know base current, we can find out ratio IE upon IB. Now please remember IE upon IB, it will be 1 plus beta, okay. Everybody knows relation between emitter current and base current. Emitter current is 1 plus beta times base current. तो हम यहाँ से 1 plus beta फाइंड कर लेंगे। आप रेशियो फाइंड करिए 3 मिली एम्पियर डिवाइडेड बाई दिस, it is 90.91. 1 plus beta is 90.91. तो अगर आप बीटा फाइंड करेंगे it will be 89.91. So in this numerical answer type question, transistor has a beta how much? 89.91. Okay, I have got answers from some of you. Yes, but 89.91 is the correct answer. Hope everybody followed this question. It's a relatively easy one. Such question can come maybe for 1 mark in the GATE paper, okay. Then let us move to next question. Now in this question we have got 2 silicon transistors interconnected, and it is mentioned that these transistors have a very high beta, okay, beta infinite. Now when question says beta infinite, then we can ignore base current in the solution. So please remember, when beta is given as infinite, you can directly ignore base current and you can take collector current, emitter current approximately equal, fine. And it is told that input is varied, this Vi is varied from 1 volt to 5 volt, then which of the following is true? This is again in MSQ, where more than one option can be correct. Input is varying here from 1 volt to 5 volt, and the options are about maximum V0, minimum V0, and it is about some operating region also. I have included multiple calculations in a single question to give you an overall idea. Let us first take input 1 volt and analyze the circuit. First consider input as 1 volt, and I have told already beta infinite, so we will ignore base current and we will take ICI approximately same. Let me show here voltage VBE. Here also I can indicate VBE, and here we can show current IE, emitter current, let us call it IE1. That IE1 I am going to calculate here. It will be VI minus VBE divided by 100 ohms. That 100 ohm I will convert into kilo ohms. It is 0.1 kilo ohms. Okay, so it is 0.1 K in the denominator. अब आप यहाँ पर VI पुट कर दो 1 volt and VBE 0.7, 1 minus 0.7 divided by 0.1. I am getting emitter current 3 milliampere. Okay, 3 milliampere, and we will take collector current approximately equal to emitter current. Okay, beta value not given here. Question says beta infinite, so we can ignore base current, take ICI approximately same. So this is like 3 milliampere. Now you indicate voltage here as VC1, voltage at collector of Q1. That VC1 I can calculate. It will be 12 volt minus drop across 2K. Okay, from the 12 volt you subtract drop across 2 kilo ohm resistor, you will get voltage at the collector of Q1. VC1 is equal to 12 minus 2 IC1. अब आप IC1 की प्लेस में लिख दो 3 मिली एम्पियर. Resistor is in kilo ohm and current is in milli ampere. Kilo into milli, it will cancel out, so it will become 12 minus 6 volt. 6 volt. Fine. Now once we know VC1, we can calculate V0. V0 will be VC1 minus VBE. I can write here V0 as VC1 minus VBE. V0 is equal to VC1 minus VBE. So I am getting here output 5.3 volt. When input is 1 volt, output of the circuit is how much? 5.3 volt. Let us also calculate output when input is 5 volt. Let us repeat same calculation by taking input as 5 volt. Let me take here input 5 volt. If VI 5 volt, then IE1, it will be equal to, I am using same approach, 5 minus 0.7 divided by 0.1. It will become 43 milliampere. 43 milliampere. Now there is a twist here. IE1 we got 43 milli. If I take IC1 equal to IE1, then IC1 should also be 43 milli. But if you take IC1 43 milli, then the drop in this 2K resistor, it will become how much? 43 into 2, I think 86 volt. It will become 86. But can we get a drop 86 here when supply is only 12? Practically it is not possible. Okay, with a supply 12 volt, you cannot get a voltage drop 86 volt. So what I tell here is, if you take IC 43 milli, if IC1 43 milli, then this drop will exceed the supply of 12 volt, and as a result VCE of this Q1 will become negative. अगर आप इस लूप में KVL अप्लाई करेंगे and if you calculate VCE1, you will get a negative value. That calculation I leave it to you. अगर आप इस लूप में KVL अप्लाई करते हैं, you will get VCE1, collector to emitter voltage of Q1, you will get VCE1 as a negative value. VCE1 becomes negative. Now please remember, for NPN transistor VCE cannot be negative. For NPN transistor, collector to emitter voltage cannot be negative. For NPN transistor, VCE should be always positive value. So what I can conclude here is I am getting a VCE negative, that means VCE less than VBE. Now everybody knows well, when VCE less than VBE, that transistor will be in saturation region. Whenever you get VCE less than VBE, you can directly say transistor is in saturation. Q1 is in saturation. And please remember, if a silicon transistor is in saturation, then that VCE1 can be taken as VCE sat. And VCE sat for a silicon transistor is 0.2 volt. It is mentioned in the question, silicon transistor, and everybody knows well, for a silicon transistor VCE saturation is how much? 0.2 volt. So I have taken VCE1 as VCE sat 0.2 volt. Okay. Now once we know VCE1, we can calculate this VC1. उसको मैं यहाँ पे लिख देता हूँ. VC1 is equal to VCE1 plus VE1. Okay, VC1 का मतलब होता है voltage between collector of Q1 and ground, and that voltage will be VCE1 plus voltage between emitter and ground. VCE1 हमें पता है 0.2 volt, and voltage between emitter and ground, it will be VI minus VBE. 5 minus 0.7, it will be how much? 4.3 volt. Okay, so this will become 0.2 plus input is 5 volt. उस 5 volt में से आप VB को subtract करिए, you will get voltage at the emitter. Okay, 5 minus 0.7, how much? 4.3. So it will be 4.3 here. I am getting it as 4.5 volt. Okay, now you can calculate V0. अगर आप V0 find करेंगे, it will be VC1 minus VBE2. VC1 को हमने फाइंड किया है 4.5, 4.5 minus 0.7, 4.5 minus 0.7, it will be 3.8 volt, 3.8 volt. So this is the value for V0. So what we can conclude here is, when input is 1 volt, I am getting output 5.3, and when input is 5 volt, I am getting output 3.8. Therefore 5.3 is the maximum output here and 3.8 is the minimum output. So in this way option A and B are correct. Option C will be wrong here, because when input 5 volt, Q1 is in saturation, so option C यहाँ पर गलत है. And option D, when input 2 volt, Q1 is in saturation, that you can prove yourself. अगर आप इसी तरह का calculation repeat करते हैं by taking VI 2 volt, you will again get similar conclusion. VCE1 नेगेटिव निकल कर आएगा, तो हम कह सकते हैं कि when input 2 volt, Q1 is in saturation. This I leave it to you. आप बिल्कुल इसी तरह से कैलकुलेशन को रिपीट करिए, you will get same conclusion, VCE less than VBE, so Q1 will be in saturation. So in this MSQ, the correct options are A, B and D. And I hope everyone in this session has tried this question. I can see in the comments, some of you have given answer A, B, D, and a few of you have given answer A and D, but A, B, D is the correct answer. Okay, only option C is wrong here. Option A, B and D, they are correct. So in this question I have given you some idea about operating region, which is an important area from where questions come in the GATE paper. From BJT topic, operating region is an important area. Okay, so please prepare that topic thoroughly. Let us move to the next question. Now this question is based on some CMOS circuit. We have a P channel MOSFET and one N channel MOSFET, and we have to find out current I. Now these type of questions also are coming regularly in the GATE paper. Okay, this circuit is similar to CMOS inverter. It is not exactly a CMOS inverter. you can just call it CMOS circuit, okay, where upper MOSFET is PMOS and the lower one is NMOS. और हमें यहाँ पर फाइंड करना है करंट I की वैल्यू, and some data is given, mu n COX, mu p COX, and W by L ratio for NMOS, PMOS, and threshold voltage 1 volt. Now first of all what you can observe here is, in this resistor R, अगर हम इस रेजिस्टर R को देखते हैं तो यहाँ पर करंट जीरो फ्लो करेगा, बिकॉज गेट करंट फॉर ए मॉसफेट इज जीरो. अगर आप यहाँ पर करंट को दिखाते हैं, इट विल बी गेट करंट, इट इज जीरो. एवरीबडी नोस वेल, फॉर ए मॉसफेट गेट करंट इज जीरो. ओके, गेट करंट विल बी जीरो बिकॉज देर इज इंसुलेटर सिलिकॉन डाइऑक्साइड प्रेजेंट बिटवीन गेट एंड चैनल. Okay, in case of MOSFET there is a insulator SiO2 present between gate and channel, and because of that current flowing into the gate terminal will be zero. So gate current is zero. So in that way, through KCL you can say current in this path should be zero. Okay, it's like 0 plus 0. So current in this resistor will be zero. If current in this resistor is zero, then drop across resistor will be zero. Okay, whenever current in a resistor is zero, voltage across that resistor will be zero. Now because this resistor voltage is zero, we can say drain voltage and gate voltage will be same. If you look at PMOS, this is drain terminal and this is gate. This voltage is zero, so we can say drain and gate will be at equal potential. And for NMOS also, drain and gate, they are at equal voltage. Now please remember, for enhancement MOSFET, if drain and gate are at equal voltage, then that MOSFET will be in saturation region. Hope everybody able to recollect this property. When you deal with enhancement MOSFET, it can be N channel enhancement MOSFET or it can be P channel enhancement MOSFET. Whenever drain and gate are at equal voltage, then that enhancement MOSFET can be considered in saturation region. So in this question we can consider both PMOS and NMOS in saturation region. Hope everybody understood this point. Drain and gate are at equal voltage. मैं यहाँ पे लिख देता हूँ, VD is equal to VG. It means both NMOS and PMOS are in saturation. Okay, now these MOSFETs are in series, we can equate their currents. Okay, whatever current flows through PMOS, same current flows into NMOS. तो मैं यहाँ पर दोनों के currents को equate कर देता हूँ. MOSFETs are in series, we can equate their currents. IDSN is equal to ISDP. Okay, आप यहाँ पर voltages को दिखा दो. This will be VSG of the PMOS, और यहाँ पर हम voltage को दिखाएंगे VGS of the NMOS. Is that okay? And I will assume this voltage as some Vx. Let me assume that unknown voltage as Vx. This node voltage we don't know, उसको हमने assume किया है as Vx. Now because MOSFETs are in saturation, we can apply saturation current equation. This will be mu n COX divided by 2 into W by L into VGSN minus VT whole square is equal to current for a PMOS, उसको हम लिखेंगे mu p COX divided by 2 into W by L into VSG of the PMOS minus mod VT whole square. This is how I write current for P channel MOSFET. Okay, VSGP minus mod VT whole square. Now you substitute the data here. Mu n COX 20 micro, so 20 divided by 2 into W by L. For NMOS, W by L how much? 3. So this will be 3 into VGSN minus VT whole square. अगर आप यहाँ पर observe करते हैं that VGSN it will be same as Vx. This drop is 0, तो same Vx आपको यहाँ पर भी दिखाई देगा. Okay, drain potential को हमने Vx assume किया है. Gate potential will also be Vx. बिकॉज ड्रॉप अक्रॉस रजिस्टर इज 0. तो हम सेम Vx को यहाँ पर भी दिखा सकते हैं. इन दैट वे VGSN इट विल बिकम सेम एज Vx. आप यहाँ पर भी वोल्टेज को दिखा दो, इट विल बी सेम एज Vx. तो जब आप VGSN लिखेंगे इट विल बी हाउ मच? Vx. सो दिस बिकम्स Vx minus threshold voltage 1 volt whole square is equal to mu p cox. This is given as 10. If you look at the question, this parameter given as how much? 10 micro. So it is 10 divided by 2 into W by L of PMOS, it is 15 into VSGP. VSG का मतलब होता है source to gate voltage. Source voltage is 3 volt here and gate voltage how much? Vx. तो जब आप VSG of the PMOS लिखेंगे it will be 3 minus Vx. Okay, source voltage minus gate voltage, it is 3 minus Vx. So this becomes 3 minus Vx minus 1 whole square. Okay, अब आप इसको simplify करिए बेटा. This 2 will cancel out. This will become 60 and here we have 150, right? तो इसको मैं इस तरह से लिख देता हूँ. Vx square plus 1 minus 2Vx. I have expanded a minus b whole square is equal to this 150 divided by 60. If you find 150 divided by 60, it is 2.5 into 2 minus Vx whole square. This becomes 2 minus Vx. उसको भी आप expand कर लो. 4 plus Vx square minus 4Vx. Okay, it will now become quadratic equation. इसको मैं यहाँ पे लिख देता हूँ. 2.5 Vx square minus Vx square, it becomes 1.5 Vx square and minus 10 Vx plus 2 Vx, it will be minus 8 Vx and plus 10 minus 1, it will be 9 is equal to 0. Okay, अब आप यहाँ से Vx की वैल्यू फाइंड करिए बेटा. It's a quadratic equation and everyone knows how to find out roots for a quadratic. So please find out what should be Vx. I did this calculation already. So it will be 3.72 and 1.612. 3.72 volt and 1.612 volt. When you solve that quadratic equation, you will get two roots, 3.72 and 1.612 volt. Is that okay? I hope everybody getting the same values. All right. Now you decide which Vx is correct. Now please remember, this Vx cannot be greater than 3 volt. Supply 3 volt hai and ground means 0 volt. So Vx should be between 0 and 3. Okay, Vx is a node between supply terminal and ground. So Vx should be between 0 volt and 3 volt. So Vx cannot be greater than 3. तो उस तरह से आप इस वैल्यू को इग्नोर कर सकते हैं. The correct will be 1.612. So correct Vx is 1.612 volt. Now once we know Vx, we can say VGSN is same as Vx 1.612. Okay, VGS of NMOS it will be same as Vx only. फिर आप करंट I को फाइंड कर लो. I is equal to IDSN, drain current of NMOS. You can use current equation for PMOS also, no problem, you will get same answer. I have written I equal to IDS of the NMOS. Now mu and COX 20 micro divided by 2 into W by L, that is 3 into VGS minus VT whole square 1.612 minus 1 whole square. अब आप यहाँ से करंट की वैल्यू फाइंड करिए बेटा. 1.612 minus 1 whole square and that multiplied with 30, right? I am getting an answer 11.23 microampere. Okay, we were asked to find current I in microampere, so the correct answer is 11.23. I hope everyone has tried this question. Yes, I can see answers from Harsh, then Lahari, Avi, Ritik, yes beta, most of you have given the answer, wonderful. Now this shows that your preparation is going on very well. Okay, the purpose of this session is to give you some ideas from where questions can come, right? These are the important areas from where questions will come, and if you're getting correct answers, it means your preparation is going in the right direction. Okay, that should boost your confidence. Please remain motivated till the day of exam. Okay, keep preparing. Fine, sometimes mistakes happen in the preparation part, that's okay. Keep preparing, don't lose confidence, remain motivated. Fine, these are very crucial days for you. आपने पिछले एक साल में जो भी तैयारी की है, that result of that preparation depends on how you keep yourself in these remaining 10 days. Okay, so remain motivated, keep putting more and more efforts in the preparation. Fine, let's move to the next question. Now this question is again based on MOSFET, and we have to calculate this R equivalent. That R equivalent is a resistance between drain and ground. We have to find here resistance between drain terminal and ground. Fine. So what we will do here is we will first of all do some DC analysis. Let me indicate here VGS. Okay, फिर आप यहाँ पर करंट को दिखा दो IDS, and just apply KVL here. KVL, I am doing a bit of DC analysis to calculate GM, transconductance. तो पहले हम उस लूप में KVL अप्लाई कर लेते हैं. It will become VGS plus 10 IDS minus 5 is equal to 0. ठीक है, और मैं यहाँ से लिख देता हूँ ड्रेन करंट इज इक्वल टू 5 माइनस VGS divided by 10. Is that okay? Let us call it as equation 1. Then let us apply current equation. We can consider MOSFET in saturation. Saturation region is a default. Okay, तो आप MOSFET को saturation region में assume करिए and use current equation. IDS equal to mu n COX divided by 2 into W by L into VGS minus VT whole square. In place of drain current, I will write 5 minus VGS divided by 10 is equal to this parameter is given 1 milliampere divided by 2 into VGS minus 1 whole square. Okay, this you can simplify now. It will become 5 minus VGS is equal to, it will be 5 into A minus B whole square. It will be VGS square plus 1 minus 2 VGS. Is that okay? I have first applied KVL here. From that KVL I got this relation IDS equal to 5 minus VGS divided by 10. That relation I have combined with the actual equation of drain current. Okay, and this you can convert into quadratic form. इसको आप quadratic form में लेकर आइए बेटा. It will become 5 VGS square. Okay, and minus 10 VGS plus VGS, it will be minus 9 VGS, and then 5 minus 5 it will cancel out is equal to 0. अब आप यहाँ से VGS फाइंड कर लो. It will be 9 divided by 5. Okay, 9 divided by 5 it will be 1.8 volt. तो इस तरह से हमने VGS को फाइंड कर लिया. The purpose of calculating VGS is to find out transconductance. अब आप transconductance फाइंड करिए. GM is equal to, you know the formula, mu n COX W by L into VGS minus VT. This is 1 milli into 1.8 minus 1. I am getting transconductance equal to 0.8 millimole. Okay, and RDS already given 100K. Now we have to find out R equivalent. Here R equivalent is resistance between drain terminal and ground. Now to find this R equivalent, we have to replace MOSFET with small signal model. Okay, so let me replace MOSFET with a small signal model here. Everybody remembers the small signal model of MOSFET. This is GM-VGS in parallel to RDS. Okay, here you can show drain terminal. This will be gate. This is source terminal, and here you can indicate VGS. Now you show the remaining elements. In our small signal AC analysis, that supply node, it will be grounded, so 10K will appear between source terminal and ground. तो हम यहाँ पर 10K रेजिस्टर को दिखा देते हैं इस तरह से 10K, fine, and gate is grounded here, so gate connected to ground, and we are trying to find the resistance between drain and ground. So between drain and ground you apply a test voltage Vx in this way and assume here some current Ix. I am using standard approach that you learn in networks. If you want to know resistance between two terminals, then you apply some test voltage and find Vx upon Ix. Okay, I have shown current Ix, same current Ix I can indicate here also. Is that okay? Let me call this as some resistor R, fine. Whatever current flows in, the same current should flow out, fine. अब आप यहाँ पर KVL अप्लाई करिए, KVL, you will get VGS equal to minus Ix into R. Okay, इसको मैंने डायरेक्टली लिख दिया है. अगर आप KVL अप्लाई करेंगे, it will be VGS plus Ix into R is equal to 0. So from there you get VGS this much. Then you can indicate current in this path, it will be Ix minus Gm into VGS. Okay, current in this element RDS, it will be Ix minus Gm VGS. Now you can apply another KVL in this loop. KVL in this loop. Okay, you get equation Vx equal to, it will be Ix minus Gm VGS into RDS. Okay, plus Ix into R. Now in place of VGS you can substitute minus Ix into R and take Ix common and bring it to LHS. Vx upon Ix is equal to, it will become RDS plus, I am putting VGS as this much, I mean minus Ix into R, minus into minus it will become plus. So it will be like Gm into R into RDS, fine, and plus R. Now you put all the values. RDS क्वेश्चन में दिया गया है 100K, GM को हमने फाइंड किया था 0.8 मिली into R 10K, that milli into kilo it will cancel, into RDS which is in kilo ohm. So overall this will be in kilo ohms only, plus R which is like 10. So it will become how much beta? This becomes 800, 900, 910. It is R equivalent equal to 910 kilo ohms. So in this question the R equivalent between drain and ground is 910 kilo ohms, and therefore the correct answer will be option B. 910 kilo ohm is the correct answer. G1 is asking some doubt about RDS, but normally in DC analysis we ignore effect of lambda here. In AC analysis we considered the effect of RDS. Okay, that lambda will have a negligible effect on the DC analysis. So if this type of question comes in the exam, only RDS given, they didn't mention anything about lambda, but lambda will have a negligible effect on the DC analysis, तो इसलिए हमने lambda term को ignore किया in the DC analysis. Hope everybody got this answer, 910 kilo ohm. Yes, I can see answers from Shishir, then Harsh, Ritik, Ajay, and then Nikhil. Yes, beta, perfect. This is another important area. They will give you some MOSFET, they will ask you to find R equivalent. So please learn this approach also. If you know network analysis very well, you will find analog relatively easier. Okay, all basics that you learn in networks we apply in analog electronics. Let's move to the next question. Now this is also a question based on MOSFET. Here transconductance and R0 they are directly given, and we have to find small signal voltage gain V0 upon Vi. Okay. Now first of all observe that in this amplifier input is applied at the source terminal and output is taken from drain. Okay, input हमने कनेक्ट किया है with source terminal and output को हमने टैप किया है from drain terminal. So it becomes a common gate amplifier. This question is based on common gate amplifier. It is a CG amplifier, common gate amplifier, and we have to find out voltage gain. So let us replace MOSFET with a small signal model. There is no need of DC analysis here because parameters are directly given in the question. तो आप directly MOSFET को replace कर दो with small signal model and then use some basics of networks, okay, to find out that gain V0 upon Vi. Let me draw here the small signal model. This is GM-VGS in parallel to R0. That R0, RDS they are same. In some of the books this parameter is mentioned as R0, in some of the books it is mentioned as RDS. Okay, and here is gate. This voltage we can show VGS, and then do remaining connections. In our AC analysis that VDD node it will be grounded. Okay, first of all between source terminal and ground we will draw Vi. This is Vi. Okay, then between drain and ground you will get this RL, load resistor 10K. तो drain से ground के बीच में आप दिखा दो RL which is 10K. Okay, and this is V0. Then we have two more resistances, that is R2 between drain and gate. तो drain और gate के बीच में आप दिखाइए R2, उसको हम यहाँ पर दिखा देते हैं R2, and between gate and ground we have R1. So between gate and ground I draw here R1 like this. Now everyone should learn this thing thoroughly. Okay, you should know how to replace MOSFET or BJT with small signal model. This is the main part in analog electronics. Okay, amplifier analysis. Everybody should be thorough with how to replace MOSFET or BJT with appropriate small signal model. Now from here we will do our further calculations. Okay, first of all you can notice this R2 R1 they are in series. Okay, R2 R1 they are in series. So whatever V0 we have shown it will divide between R1 and R2. So if I want to know gate voltage, that gate voltage will be voltage across R1 और उसको हम find कर सकते हैं through voltage divider. Okay, gate voltage will be V0 into R1 divided by R1 plus R2, and source voltage it will be nothing but Vi. So let me write here VGS is equal to gate voltage minus source voltage. Gate voltage का मतलब है voltage across R1, उसको हम लिखेंगे through divider V0 into R1 upon R1 plus R2, okay, minus voltage between source and ground. Now that is nothing but Vi. Is that okay? अब आप यहाँ पर R1 R2 की वैल्यू पुट कर दो. R1 500K है and R2 how much 1 mega ohm, that's like 1000 kilo ohm. तो अगर आप वैल्यू पुट करते हैं it will become 500 divided by 1500, it's like V naught upon 3, right? तो ये हो जाएगा VGS equal to V naught upon 3 minus Vi. This you take as some equation 1. Okay, I have written voltage between gate and ground through voltage divider. This V naught will divide between R2 and R1. Next, let us apply KCL. अब हम KCL use करेंगे. All these currents are like, you can show them in any direction, doesn't matter. I am showing them in this way. Now apply KCL at the drain terminal. KCL at drain terminal. I have taken all currents as like flowing outward, so I will get sum of these 4 currents equal to 0. Okay, तो आप currents को लिखते जाइए बेटा. It will be GM VGS plus what will be current in this path? It will be V naught divided by R1 plus R2. V naught upon R1 plus R2. Okay, plus what will be current in this element? It will be V naught minus Vi divided by R naught. V naught minus Vi divided by R naught plus current through RL. It will be V naught upon RL is equal to 0. Okay, sum of these 4 currents is equal to 0. अब आप यहाँ पर VGS की प्लेस में लिखिए V naught upon 3 minus Vi, so it will become GM into V naught upon 3 minus Vi, okay, plus V naught upon R1 plus R2 इसको हम इस तरह से लिख देंगे V naught upon R naught minus Vi divided by R naught plus V naught upon RL is equal to 0. अब इस इक्वेशन को आप थोड़ा सा रीअरेंज कर लेना. You will get gain V naught upon Vi. I am writing it here. V naught upon Vi is equal to, you have to rearrange it बेटा. इसको आप rearrange कर लो. It will be GM, directly मैं value put कर देता हूँ. GM how much? 1 milli. So 1 plus 1 by R naught, which is like 1 by 100 divided by, you will get GM by 3 in the denominator, 1 by 3 plus 1 by R1 plus R2, that will be like 1 divided by 1500 plus 1 by R naught, which is 1 by 100 plus 1 upon RL, which is like 1 by 10. आप इसको थोड़ा सा rearrange कर लेना. You will get V naught upon Vi in this way, and from here you calculate the gain. अगर आप gain find करेंगे, it comes out as 2.27. You will be getting a voltage gain 2.27. Yes beta, I have got answer from Yagala Ishwar. D, 2.27 is the correct answer. It was a question based on common gate amplifier. Once you replace MOSFET with the small signal model, then you should start using basics of network analysis. Okay, I have used KVL. हमने KVL नहीं, हमने पहले VGS को लिखा, VG minus VS, फिर हमने इस नोट पर KCL को अप्लाई किया, and in that way we got the answer 2.27. Yes beta, Mohak Sinha, 2.27 is the correct answer. Abhinav Datta, 2.27, yes beta, perfect. Option D is correct here. Such question can come for 2 marks in the exam. Okay, this type of questions can be asked for 2 marks in the GATE paper. Let us move to the next question. Now this one is based on a BJT amplifier, and we have to find out the gain V naught upon Vi. Okay, we need to find out voltage gain V naught upon Vi. Now if you observe carefully that Q1, it's a PNP transistor, it's a PNP transistor, emitter is up here and collector is down. Input हमने अप्लाई किया है at the base terminal and output taken from collector. So Q1 is a common emitter amplifier. Okay, Q1, it's a PNP transistor, it is acting like a common emitter amplifier because input present at the base and output taken from collector. That emitter is up here. So it's basically common emitter amplifier. मैं यहाँ पे लिख देता हूँ Q1, it's a common emitter amplifier. Okay. Now Q2, Q3, they are NPN transistors and they form a current mirror. Everybody knows basic BJT current mirror. Those Q2, Q3, they form a current mirror. Okay. तो पहले आप करंट फाइंड करो बेटा, फाइंड आउट दिस करंट. इसको हम लिख देते हैं सम, लेट अस से I1. ओके, दिस इज VBE. तो आप करंट I1 को फाइंड कर लो. इट विल बी 3 माइनस VBE, 3 माइनस 0.7 डिवाइडेड बाई 23K. It will be 0.1 milliampere, 0.1 milliampere. Okay. Now it is told in the question that transistors have large beta, and there is one more hint given. Q2 has emitter junction area 5 times that of Q3. Okay, Q2 has emitter junction area 5 times that of Q3. That means current in Q2 should be 5 times. Everybody knows property of a BJT. Current is proportional to the area of emitter junction. Here Q2 has emitter junction area 5 times that of Q3. So current in Q2 should be 5 times. 5 I1. It will be 0.5 milliampere. Is that fine? If Q2, Q3 had same area, then we can say I2 equal to I1. But here Q2 has area 5 times that of Q3. So current in Q2 will be 5 times the current in Q3. So in that way we got I2 0.5 milliampere. Now that same I2 will become the collector current of Q1. तो अब आप Q1 के लिए ट्रांस कंडक्टेंस फाइंड करिए. GM इक्वल टू IC अपॉन VT. That IC is nothing but 0.5 milli, and thermal voltage it is given in the question 25 milli. Okay, 0.5 divided by 25, I am getting answer 20 millimho. 20 millimho. And also observe that current mirror will act as a load for Q1. Okay, in this amplifier, Q1 is an amplifier, Q2, Q3 they form current mirror, and that current mirror will act as a load for Q1. And you know very well, when current mirror used as a load, that current mirror will be replaced by its output resistance. For a current mirror, output resistance or equivalent resistance, it will be nothing but R0 of this Q2. तो इस entire current mirror को हम replace करेंगे with its R equivalent. Okay, इसको हम replace कर देंगे with R equivalent equal to R02. Is that fine? We have to consider R0 of Q2. Hope everybody remembers. BJT current mirror or MOSFET current mirror, it has a equivalent resistance R02. तो हम इस current mirror को replace कर लेंगे with R02. Then circuit can be redrawn in this way, that R02 will become a load. This is 100 ohm that I call as RE, 0.1 kilo ohm, and here is VI. Okay, this R02 will become load for Q1. अब हम कह सकते हैं कि for this common emitter amplifier, load is how much? R02, and between emitter and ground you have a resistance RE. तो जब आप इस common emitter amplifier के लिए gain find करेंगे, you should apply the formula of common emitter without bypass. Okay, between emitter and ground you have a resistance RE. So to find gain, V0 upon Vi, I will be using this type of formula. minus gm into RL divided by 1 plus gm into RE. I hope everybody remembers this formula, common emitter amplifier without bypass capacitor. अब आप यहाँ पर values put करिए बेटा. RL will be nothing but R02 which is given in the question. Q2 has a R0 50K and RE 0.1K, trans conductance 20 milli. और हमें यहाँ पर magnitude find करना है, so you can take modulus mod V0 upon Vi. It will be 20 milli into 50 divided by 1 plus 20 into 0.1. Okay, denominator becomes 3, so it's like 1000 divided by 3. 1000 divided by 3, it will be 333.3. So in this amplifier, the voltage gain magnitude is 333. Option A will be correct answer. Yes beta, option A will be correct. Yes Mohan Kumar, I have done the same thing beta. Current mirror को हमने replace किया with R02. I hope everybody is enjoying this session, right? I have selected some good quality questions and these are important questions also. This type of questions can come in the upcoming GATE paper. In this question we have used current mirror as a load. इसको हम कहते हैं active load. Current mirror को हमने यहाँ पर use किया है as a load. Let's move to the next question. Now this question is based on cascode current mirror. This type of circuit is called a cascode current mirror. It is a type of MOSFET current mirror. We call it cascode current mirror. And all MOSFETs, they have Kn dash 100 micro and W by L given 10, threshold voltage 1 volt. We have to find the minimum value of V0 such that circuit acts as current mirror. Okay, we should find out okay, what should be minimum V0 value such that circuit acts like a current mirror. Now please remember, for a MOSFET current mirror to give proper operation, all MOSFETs should be in saturation. A MOSFET current mirror will have proper operation provided all MOSFETs are in saturation region, whereas in BJT current mirror all BJTs should be in the active region. So let us first of all calculate VGS. Now remember that I out, I reference, they will be same, it's a current mirror, and all these MOSFETs they will be having same VGS. तो मैं यहाँ पर VGS को दिखा देता हूँ, VGS. This is also VGS. All these MOSFETs they will have same VGS. तो अगर आप यहाँ पर KVL अप्लाई करते हैं in this loop, okay, you will get I reference equal to, मैं इसको डायरेक्टली लिख रहा हूँ, I hope everybody understood. It will be 10 minus 2 VGS divided by 2. अगर आप इस लूप में KVL अप्लाई करेंगे you will get that equation. 10 is equal to 2 into I reference plus VGS, okay. उसको आप rearrange कर लो, you will get I reference equal to this much. Then use current equation for saturation, mu n CoX by 2 into W by L into VGS minus VT whole square. अब आप IDS की प्लेस में लिख दो this reference current 10 minus 2 VGS divided by 2. Now mu n CoX, that is your Kn dash. यहाँ पर Kn dash का मतलब होता है mu n CoX. It is given as 100 micro. उसको आप मिली में कन्वर्ट कर लो, 0.1 मिली divided by 2 into W by L, that is 10 into VGS minus 1 whole square. Okay, that Kn dash is nothing but mu n into CoX. उसको हमने मिली एम्पियर में कन्वर्ट किया, 100 micro became 0.1 milli. That 2 will cancel out. अब आप इसको थोड़ा सा सिंप्लीफाई करिए, 10 minus 2 VGS is equal to A minus B whole square. It will become VGS square plus 1 minus 2 VGS. This also cancels and you will be getting VGS equal to 3 volt. You will get +-3, -3 को हमने इग्नोर किया क्योंकि VGS कैनॉट बी नेगेटिव हियर, VGS हैज़ टू बी पॉजिटिव वैल्यू. दिस आर n channel enhancement MOSFETs, they must have a positive VGS. So I have considered +3, VGS equal to +3. Now what you do is you indicate VGS everywhere. This is also VGS. Okay, अब आप ये करिए, इस नोड पर वोल्टेज को फाइंड करिए बेटा. लेट अस कॉल इट सम Vx. इसको मैं लिख देता हूँ Vx. Try to calculate Vx. To find that Vx, you can apply KVL in this loop. आप इस तरह से KVL अप्लाई करिए. Okay, you will get Vx equal to minus VGS plus VGS plus VGS. Okay, हमने यहाँ पर वोल्टेज को अस्यूम किया है Vx like this. तो अगर आप KVL अप्लाई करेंगे you will get Vx equal to minus VGS plus VGS plus VGS. ये minus VGS plus VGS कैंसिल हो जाएगा. It will be simply VGS only. Vx equal to VGS. Is that fine? Vx equal to VGS. Now for this circuit to act as a current mirror, that MOSFETs must be in saturation. Okay, that M4 must be in saturation. तो वो वाला कंडीशन हम अप्लाई करेंगे. For proper operation, M4 should be in saturation. All MOSFETs should be in saturation. Okay, so M4 should also be in saturation, and you know the condition for saturation, VDS4 should be greater than or equal to VGS minus VT. Condition for saturation region. Now what is VDS4 here? अगर आप ठीक से देखते हैं that VDS4, it will be V0 minus Vx. Okay, V0 minus Vx, V0 minus Vx greater than or equal to VGS minus VT. अब आप Vx की प्लेस में लिख दो VGS. Vx is nothing but VGS, and you can take it to the other side. You get condition V0 more than or equal to 2 VGS minus VT. Is that okay? So this is the minimum V0 value. In a cascade current mirror, that V0 should be at least this much. Only then you will get I out equal to I reference. Fine. अब आप यहाँ पर डेटा पुट कर दो. VGS को हमने फाइंड किया था, how much? 3 volt. So it will be like 6 minus 1. V0 should be greater than or equal to 5 volt. So the minimum V0 will be 5 volt. Okay, the minimum V0 required for proper operation of this current mirror will be 5 volt. I hope everybody understood this question. Minimum V0 should be 5 volt. So this was question based on MOSFET current mirror. Please prepare current mirror properly, right? BJT current mirrors, MOSFET current mirrors, there is a high possibility that questions may come from here. If you look at BJT MOSFETs, the important areas are in the BJT, question can be from operating region topic, question can be based on BJT biasing circuits, it can be about BJT current mirrors, or question can be from small signal analysis of BJT amplifiers. And when you go to MOSFETs, in MOSFETs the question may come from MOSFET biasing topic or MOSFET current mirror topic, or question can be from small signal analysis of MOSFET amplifiers. They can ask you questions based on current mirrors, MOSFET current mirrors, and electronics batch question can come from CMOS inverter also. Especially electronics batch, CMOS inverter is also important area. For electrical batch, you can focus on MOSFET biasing circuits, MOSFET current mirror, and small signal analysis of MOSFET amplifiers. So these were questions which I have taken up. There are some more questions. For example, this is a question based on calculation of lower cutoff frequency. That is another area which can be asked in the GATE paper. Okay, they will give you some amplifier and they will ask you calculate lower cutoff frequency, calculate higher cutoff frequency. Okay, here I have taken up one question on calculation of lower cutoff. We have to find here lower cutoff due to this C2 1 microfarad. Now this is basically a common drain amplifier. It's a common drain amplifier. Input is given at the gate and output taken from source terminal. Okay. Now what you have to do here is, I will tell you the approach. Okay, you have to find out resistance seen from here. उसको हम लिख देंगे R0 dash. Okay, that resistance you are supposed to find out. जब आप R0 dash find कर लेंगे, then circuit can be redrawn in this way. This R0 dash, this is 500 ohm that we can take as RL, let us say RL equal to 500 ohms, and this is your capacitor C2. Now your task is to find this R0 dash. आप उसको calculate करना, that I leave as a self exercise for you. You know how to find output resistance for a given amplifier. You have to replace MOSFET with small signal model and then apply a test voltage Vx between source terminal and ground and calculate Vx upon Ix. That calculation part you carry out. You will get R0 dash 1 upon Gm in parallel to this resistor. इसको मैं लिख देता हूँ Rs. Okay, 1 upon Gm in parallel to Rs. This calculation you try out. It will be 1 upon Gm. How much? 1 upon Gm will become 200 ohms. In parallel to Rs, 1000 ohms. Okay, that 200 in parallel to 1000. You will get a value 500 by 3, that is like 166.67 ohms. And RL is 500 ohms. You know general formula for cutoff. Cutoff general formula is FL equal to 1 by 2 pi R into C. That R is resistance seen by that capacitor. Now if you observe the resistance seen by this capacitor, it will be R0 dash plus RL. Okay, that R is equal to, it's like how you calculate time constant in networks. Now these values you can substitute here. Let us just do this calculation. Capacitance is 1 microfarad. I am getting a value 238.7, roughly like 239 hertz. 239 hertz. So in this question, lower cutoff frequency is 239 hertz. Okay, so please prepare this area also, calculation of lower cutoff, higher cutoff. Okay, so with this I conclude my discussion on BJT and MOSFET. There are questions on op-amp circuits and diode circuits, and those will be taken up by my colleague dear Rajkumar sir. So please wait for 30 seconds.
Very good evening, dear students. I hope you have been enjoyed BJT and MOSFET questions by Ifteqar sir. Very good quality questions. Let me complete diodes and op-amp questions related to the diode and op-amps. Okay, I hope you are all doing well. So, some areas I am covering which are very important areas. When you are going for the GATE exam, please try to develop that concepts very well. Okay. So, first I will start with the diode question. Assuming a constant voltage drop model, plot V0 V out as a function of IIN for the circuit shown below. Generally in any GATE exams, most of the GATE exams, whenever you go, they will give input to output characteristics, but this is a type of peculiar questions where current source will become the input, where the output they will ask you the characteristics between output and input. So, it may give current source or it may give voltage source. You should not get confused. The main method which we use for clipper questions, I think this is a clipper question, perfectly if you see, it is a clipper question. So, you should not get tension on clipper questions. Only thing is we must know the diode status, when it will be on, when it will be off. Okay, to find out that we have the best method called as open circuit test method. So, let me simply use that technique to finish this problem. So, assume diode is off. Always in clippers use this method, diode is off I have taken. If you take here diode off, the circuit looks like this. This is the current source IIN, and we have a resistance here R1. Simply make diode as open with some voltage called VD, and this will become your output. Just we must know what is the VD value in the circuit. By using some networks basics, it is very easy to find out what is VD here. VD is nothing but here current into resistance. So, just VD formula can be written as IIN into R1. Just you got some relation between the voltage drop across a diode with respect to current IIN. So, now the point here is he has used a concept called constant voltage drop model. Generally when we study diodes, we have three different models we use. One is called ideal modeling, one is called CVD model, that is constant voltage drop model, one is PWL model, okay, piecewise linear model. In CVD model, what is the concept we have to apply is, if VD, if it is greater than VD on, your diode will be on. This is the concept. Your diode voltage drop should be greater than the cut-in voltage of the diode, which is called indicated as VD on. So, if VD on, if you cross, the diode will come into on condition. So, the VD here we have is IN into R1 should be greater than VD on, then the diode will be on. So, how much current is required here to make the diode on here is IIN should be greater than VD on divided by R1, where you are making your diode will be on. So, this is the condition which we got where the diode will come into on condition. So, your current IIN should be greater than VD on divided by R1 times, then the diode will come into on condition. So, when diode comes into on, it is replaced with a battery, just it is replaced with a battery, constant battery, that is VD on. So, the output will become simply VD on. When diode comes into on, we are replacing the diode with a constant battery called as VD on, such that the output will become V0 is equal to VD on. If the same concept if you apply for reverse analysis, if IIN is less than VD on divided by R1, if the condition is reversed, if the current is less than VD on by R1, then the diode will come into off condition. When the diode is off, it looks like this, the circuit. So, it is an open circuit. So, VD or V0 both are same here, which will be equal to IIN into R1. So, it is behaving like some Ohm's law we are getting. So, by these two conditions, you can see there are 4 options here, which will be the best answer, you can understand the question. Okay, I will see your chart box. How many has written correct answer? I'll see. So Monu, you said A, Nikhil C, Ishwar A. Okay. Some people are telling A, some people are telling C. Let's see the answer. V naught equal to Vd on for IAN greater than Vd on by R1. I think if you see here, B answer, Vd on divided by R1, if you are greater than, it will be Vd on. If it is less than, it's a Ohm's law, output is equal to IN into R1 means it's just like a line passing through origin, having a slope of simply R1. I think it's matching with your option B will be the correct answer. So like this you can easily complete the problems of clippers. Okay, most of the times they give with VIN to V0. Sometimes they may give with current source also. You should not have a tension by seeing current source, it's a complicated problem. Like that you should not think. It is also having same method. Making the diode open circuit, you have to start the same process. Okay, this is one important area to cover in gate field, gate competitive exams. It may be EC, electrical or instrumentation. It's one of the important areas, so be perfect with clipper questions. Okay, so this completes my first question. Let me start with the next question. Okay, next question will deal now. Next problem. So I have mixed the problems now. Some are diode problems, some are op amps. Like that I mixed. Don't worry about that. Now if you see this question, one time read this question. Calculate the closed loop gain of a non-inverting amplifier shown in figure. Okay, calculate the closed loop gain of a non-inverting amplifier shown in figure. If A0 is infinite, here A0 we call it as open loop gain is infinite. He has given the condition, and R1 is 0. This R1 he made it as 0 means we can make as a short circuit. So if you make this R1 short circuit, how it looks? First I'll redraw the diagram. This is plus, minus, this is your output, V out. We have R3, this is R3, this is R4, this will become R2, and this is your input. The circuit is looking like this. If I make R1 is equal to 0, the problem is looking like this. So you can catch the answer for this. Meanwhile, you can analyze the answer for this question. What will be the option for this? Please try to find out the answer for this question. Yeah. So most of the students are giving B answer. That is a previous question answer, I think. Yeah. So Monu is telling C is the answer. Yes, great. So if you see clearly this question, plus is at the top side, minus is in the bottom side. If the same diagram, if I rearrange like this, if I rearrange, it looks like this. Plus will take it as bottom, minus sign will take it as top. This will become your output V0. Plus side we have the input voltage VIN. Minus side we have some feedback, that is R3. This is a feedback, and R2 is connected to ground, and R4 which is behaving like a load here. Exactly, if you see this diagram and this diagram, both are same. So for your convenience in op amps, plus to minus, minus to plus, you can change it, and you can understand the exact behavior, how it looks. Okay, it's exactly looking like a non-inverting amplifier. It's a very standard amplifier. It's a non-inverting amplifier because the input is at the non-inverting side, and you consider this R4 as a load resistance and R3 as a feedback resistance or shunt resistance we can say, and R2 we can take it as a series resistance, or we can say it's a series resistance we can take R2. So what is the non-inverting amplifier gain? That must be the answer. It's a non-inverting amplifier. It's a non-inverting amplifier. It's a very trick question. So the answer will be the gain he is asking, closed loop gain. that is ACL, which is 1 plus, generally the formula is RF by R1 we take. That means if you consider this as RF and this is R1, so the answer is 1 plus RF by R1 is the non-inverting gain. Here RF is R3, so 1 plus R3 is the feedback resistance, and series resistance R1 is covered by R2. So like this you can finish this problem. Okay, like that the questions will be in your GATE exams. Don't feel that always tough questions will come in the exams. Okay, tricky based questions will be there. Some questions may be trick based with the toughness will be there, but if they have given suppose 4 to 5 questions in analog, don't expect all the questions will be tough. Okay, some are moderate, some are easy, some are tough questions. Okay, don't keep your mind always that the total question paper will be tough. Okay, you will get more tension in the exam and you cannot do the performance well. Okay, be cool and do the questions. Whatever you read until whatever you have been till now you have been prepared, make it as a perfect and try to start doing the problems. Okay, anyway this is the answer for this question, 1 plus R3 by R2. I think most of the students have given C is the answer. That's great. That's great. Nice. So most of the students are giving correct answer. That's great. Let me cover the next question based on diode again. Okay, I am going for the next question based on diodes. If you see this question, I think most of the students got an idea. It's just a rectifier area I am covering. Okay, it's like a rectifier question. The input is a sine wave. The input is a sine wave given by Vi is equal to 10 sin omega t. Okay, the peak amplitude is 10 volts he has given. Assume V gamma is 0, that is cut in voltage is at 0, means we can assume that all the diodes given in the problem as ideal, we can assume it. Determine the RMS value of the output voltage. I think first of all a student should get, before doing the problem, he should get the formulas in his mind. RMS value of a half wave rectifier, suppose the output comes like a half wave rectified output, it is Vm by 2. The formula is Vm by 2 for half wave. Suppose the answer is coming like a full wave output for example, then the answer is Vm by root 2. These 2 points should be in your mind to answer this question. Vm is nothing but the final output maximum peak value is called Vm, one peak value. Okay, it's not peak to peak, it's a peak value. So let's see this response will come as a full wave output or half wave output. Let us understand. If I take first positive half cycle reaction, positive half cycle, it's very easy. Most of the students who have basic knowledge of diodes, they can understand the position of diode very easily. You are starting from plus. When you are going like this, a D1 is opposing the current, so D1 will be reverse. It's very easy to tell. And R1 and the current may come to D2 in forward to minus. So D2 is looking forward for the current and D1 is looking reverse. So simply write D1 as reverse bias and D2 as forward bias. It's very easy to understand the path of the diodes. D1 is reverse, D2 is forward. When this is open circuit, if this is open circuit, you have plus contact to R1 and these 2 contacts will be same. These 2 contacts, that means 6.8K and 2.2K, that is R2, are coming parallel. These 2 are coming parallel and it is becoming ground point. So the model you can simply write like this. This is R1, which is 2.2K, and we are getting RL, which is 6.8K, parallel to this 2 will become ground here, R2, which is 2.2K. Okay, these 2 are coming parallel and is becoming ground. This is your input and output we have taken V0 across RL. So this is the position of the circuit for positive half cycle. So if you want to find out the output with respect to input, using networks we can finish off. So simply use a voltage division rule concept to find out the output. Just write the output as your input into these 2 resistors will take parallel, R2 parallel to R2, RL parallel to R2 divided by RL parallel to R2 plus R1. So like this you can finish the output voltage, how much we are expecting. So if you take the parallel combination 6.8K parallel to 2.2K, it is coming to be 1.66K we are getting parallel combination. 1.66K divided by 1.66K plus 2.2K. R1 is 2.2K. If you simplify this answer, we are getting 0.43 times of input. So this is the output we are expecting. Output is coming 0.43 times of input. But the input he has given, the peak value of the input is 10 volts. So if you multiply 0.43 into 10, which is equal to 4.3 volts. So the output maximum peak value we got in positive half cycle is 4.3 volts. In the similar manner, apply the negative half cycle also. Let's see the response for negative half cycle. If you apply negative half cycle, it's very common sense that D1 will become forward now, D2 will become reverse. It's opposite technique. You are going from plus to minus, from downward to upward. At that time D2 is looking reverse, and D1 will look forward. So now what happens is RL will come parallel to R1 at the top side. Now RL parallel to R1, bottom side R2 will be there. So this same model looks like this. So you have ground point at the plus side, at the top side now. We have R1, R1. This is R1, and this will become parallel to RL, and bottom we have R2. And we are giving input here. This is plus, this minus. And your output, we have taken plus to minus. If you see clearly this polarity indication, the output is negative, input is also negative. Therefore, your output will get a positive response. Vi into here R1 parallel to RL divided by R1 parallel to RL plus R2. So you simplify this calculation, it is looking like similar circuit actually. So you will get the same answer, 0.43 times of Vi. Here also we are getting the same value, 0.43 times of Vi, and Vi is at 10 volts, so it is 4.3 volts. So we are getting both the responses in positive side only, positive peak of 4.3 in positive half cycle, negative half cycle also 4.3 in the negative cycle becomes positive cycle here, because the output is negative when input is also negative, we are getting the response. So finally the output response I can show you like this. This is your output. This is 4.3, this is 4.3. So I am expecting this type of output waveform we are getting for this problem. So what will be the Vrms value of this waveform is asking. If you see, this is looking like a full wave rectifier output, just looking like full wave rectifier output. That means negative also we got in the positive side. What is the formula of full wave rectifier? Vrms value is, V out RMS value is Vm divided by root 2. This is the formula for it, for a full wave rectifier. So Vm here is, you take 4.3 is Vm. So 4.3 divided by root 2 times. So this is your output RMS value in the question. So let me write the calculated answer. How much we got the value? I am writing 3.04 volts. So this must be the calculated answer for this question. And so it may come like NAT questions, some problems maybe. At that time they will write some 2 decimal value. So don't write simply 3 volts like that, it will become mistake in the GATE exams. You have to write the decimal value also properly, okay? Otherwise it will become an invalid answer for your GATE exams. So 3.04 volts exact answer you can expect for this question. So I think most of the students have given the answer perfect. So Ratna, Saxena 3.04, Anna, Dilip, Harsh 3.04, excellent. Avi Kumar, very good, very good. Sharma, most of the students perfectly they have given the answer. Your preparation is wonderful, okay? Exactly you have given the good answer. So I am expecting this type of questions can be expected for the GATE exam. So you should have the basic formulas should be remembered by you when you are going for a GATE exam. Rectifiers, we have not only RMS value, they are asking most of the times average value in a circuit. It may be voltage average or it may be current average problems. So you should have the formulas. If you are good enough in understanding the formulas and remembrance of the formulas, doing the question will take less time for you. Okay. Anyway, this is one good question you can expect. Next question we'll see now. I'll turn to op-amp question now. Let's see one more some logical typical question we can expect. So see here properly, for a given non-inverting amplifier, again the problem is under non-inverting amplifier. It's a non-inverting amplifier. The closed loop gain is 5. First point. Okay, so you should be conscious here. Closed loop gain, I am writing non-inverting, he said, non-inverting amplifier. He said non-inverting amplifier, closed loop gain. Closed loop gain, we know the formula 1 plus R2 divided by R1, which is equal to 5. Up to here, there is no doubt about the question. Okay, so closed loop gain is completed. Next here, most of the students will get confused with this word gain error. Okay, this is called open loop gain error. We can say gain error is nothing but in any closed loop system, open loop gain will come in the formula. If you see correctly, what is the realistic formula? ACL formula is 1 plus R2 by R1. This is the accurate formula, I can say. 1 plus 1 by A naught will take open loop gain into 1 plus R2 divided by R1. This formula is correct when you are not taking V minus is not equal to V plus. That means who is not following the virtual short theory or virtual ground theory concept, at that time this must be the transfer function a student should have in your mind. Otherwise this problem you cannot attempt, because he said the gain error here. The gain error which we can see, this will become the gain error. This is your gain error. In non-inverting amplifier, this is your gain error. Because of that gain error, you cannot expect the gain will be 5. Okay, it can decrease less than 5. So this is called gain error for you. This is gain error. By open loop gain, we are getting some error. So that is given as 1%. So I am writing here 1 by A naught 1 plus R2 by R1, which is equal to 1%, which is equal to 1 by 100. 1% is nothing but 1 by 100. So 1 plus R2 by R1 is 5 he has given. So 1 by A naught into 5 is equal to 1 by 100. Simply A naught came as 500. So we finished with the first answer. That is open loop gain. Easily I solved with the gain error concept. Okay. So I think he is asking that only open loop gain. I completed open loop gain here. Not only in this question open loop gain he is asking bandwidth for this question. If you want to find out the bandwidth, then why can't you use some information he has given. Closed loop bandwidth he has given 50 megahertz. Closed loop bandwidth he has given, is asking open loop bandwidth is how much. Then immediately the student should get strike about the gain bandwidth product is constant. That logic has to come into his mind. So that means 1 into Ft, that is called gain bandwidth product, will be equal to A naught into Fh, that is open loop gain into open loop bandwidth, is equal to product is equal to closed loop gain into closed loop bandwidth. So this is one of the interesting phenomena you have to keep in mind, such that if any one parameter is missing, gain or bandwidth, we can solve very easily. Now with the help of this formula, I can solve the bandwidth for an open loop system. So generally this Fh is unknown in this question. Fh is nothing but we are considering it as a open loop bandwidth. Open loop bandwidth. So A naught we know. So Fh, which is bandwidth, will be equal to ACL into Fh of F divided by A naught. Closed loop gain how much is 5 into bandwidth is 50 megahertz divided by A naught is 500. A naught is, we got 500. If you can solve this problem, you are getting bandwidth, open loop bandwidth, which is coming to be 0, 0 here, 5, 10 times. This is 1 by 2, that is 0.5 megahertz. So it can be written as 500 kilohertz. You can expect this will be the answer for this. A very intelligent question. First open loop gain, he has tracked from the information of gain error technique. From that, he designed the question with respect to bandwidth. With the help of gain bandwidth product is constant. There are two different phenomena we have used in a single problem here. Okay, I think most of the students has given C answer here. Yeah, G1, yes, correct. We can use gain bandwidth product constant. Yes. Harsh, perfect. Yes, we have to use gain bandwidth product concept if we can apply. This is a very interesting question. Okay, such type of questions you can expect in GATE exams. Okay, only two logical points. You must know the standard formula of closed loop gain. It may be inverting or non-inverting. This error will be same always. Remember this point. Below denominator error is not due to inverting or not due to non-inverting amplifier. It is due to op-amp error we are getting. So if you have that capability, and in doing this problem is not very tough for you. Okay, anyway, most of the students has given good answer. I am very happy to see that answers. A naught open loop gain is 500 and F naught value is 500 kilohertz. Okay, so I am expecting this question is clear. Let us move to the next question. Okay, let us move to the next question. Okay, next question. I am coming to the diode problem now. I think if you see your GATE books, most of the times I have seen this type of questions called as a status problems. Which diode is on, which diode is off, this type of questions number of times will come in GATE exams. So for that, what techniques we have to apply? Let me solve one example problem. Check the status of D1 and D2. Check the status of D1 and D2. Assume that diodes are ideal. Assume that diodes are ideal. Sometimes the diode are CVD model they will ask you. That's a practical model. This is an ideal question. D1 diode is given here. D2 diode 5K, 2.5K, 10 volts. Simply my suggestion, I'll tell to my students, whenever status questions comes, which diode is on, which diode is off, in DC analysis, short circuit testing is one of the best testing which we can solve very quickly the problem. Let me apply the short circuit test, see how much time it will take. Short circuit test is one of the best method to solve this question very quickly. Short circuit test is nothing but simply make the number of whatever the diodes they have given, make it short first. This is D1, this is 10 volts, we have 5K. Next here a short I have taken D2, there is a 5 volts, and this is 2.5K with a ground. So two shorts we have, D1, D2, make it two short circuits. And where is anode, cathode? Clearly you write, this is anode, this is cathode, this is D2 diode. So the current indication you give for each diode, ID1 current here, here ID2 current. So the current indication you have to show from anode to cathode of each diode. Now what is my technique here is, if ID current comes greater than 0 in my testing, I can say that diode is on. If ID current comes less than 0, I will say diode is off. This is the simple trick. Okay? If ID is come greater than 0 in the circuit, we say diode is on. If ID comes less than 0, means simple networks we have to use. Let me see, this is ID1, this is ID2. Let me take this current as some IX. Now this position will become 5 volts. It's a short circuit, so 5. So ID1 easily you can find out 10 minus 5 by 5K, which comes to be 5 by 5K, which is nothing but 1 milliampere, which is greater than 0. So D1 is on, confirm. Then a single step we have finished the problem. D1 is on. D1 is on, but D2 whether it's on or off, let us find out. To find out this current, we'll take the help of Ix current. Your Ix is 5 minus 0 by 2.5K, which is equal to 2 milliamperes. Your Ix is 2 milliamperes. If I know this current, we can find out this current by using some KCL. KCL at 5 volts. We'll apply at the node of 5 KCL. So then ID1 plus ID2 will be equal to Ix. So these two currents will be equal to the Ix current. So ID2, if you want, it will become Ix minus ID1. Okay. So Ix is 2 milliamperes minus 1 milliampere, which is equal to 1 milliampere. Again, you got ID2 current is also a positive answer. So I am confirming that ID2 is also greater than 0, D2 is on. So they will not take much time. It may be 3 diode problems also, the same story you can apply it. Okay. Short circuit test is one of the best testing to solve this type of questions. Okay. And finally, the answer will be D1 on, D2 on. Option B will be the correct answer. Let's see our friends has given the answer or not. Yeah, very good. Very good. Most of the students, wonderful. All the students have given option B as the correct answer. Nice. It's great to see that answers from you. Very good. So with this, we have completed certain problems. First, I have been taught in diodes. Please remember clipper type of questions. That area is important. After that, rectifier questions. Be perfect with rectifiers. Next is this type of questions, status problems you can expect in the GATE exams. And coming to the next question, let us see the next problem. So again, op-amp question is coming now. Let us understand, read the problem properly. I'll also read the question. The internal circuit of an op-amp can be simplified to a 1 milliampere current source. Okay, the internal circuit of an op-amp can be simplified to a 1 milliampere current source charging a 5 picofarad capacitor. Okay, if an amplifier using this op-amp produces a sine wave with a peak amplitude of 0.5 volts, it is producing an output voltage of peak value of 0.5. Determine the maximum frequency of operation that avoids sleeving. You already studied in your syllabus sleeve rate. Okay, one important topic called sleeve rate. The sleeve rate tells you about how much the output is responding to the input. Is asking how much maximum frequency you can apply such that the output will not get distorted. That's called sleeving. The output should not get distorted. Okay. So to find out this, there are typical parameters they have given, so that may confuse the student. First, you have to track this point here. 1 milliampere current source, 5 picofarad. From where this came? First, you must know that simple story. Okay. First point, very simple point I am writing. Op-amp response will behave like a low pass response. First point. Op-amp internal response is nothing but a low pass response. First, student should know that point. It will behave like a low pass response. So if you take a low pass circuit, it looks like this. One R will be there, one C. The circuit will behave like this. This is your input, this is your output, this is your VC voltage, and there is a current here I. So the op-amp circuit will behave like a low pass. The low pass circuit is shown like this. So what is the VC voltage if I write? Output is equal to VC. VC is nothing but 1 by C integral of I into dt. Everybody knows the relation between capacitor voltage to capacitor current. Now what is sleeve rate? Which is nothing but dV naught divided by dt. You have to differentiate the output with respect to time, will give the sleeve rate. If I make this derivative for this, it becomes a dVc by dt, which will become integration will be cancelled by differentiation. So I by C will come. So this is your sleeve rate. So that means with respect to the information of current and capacitance, there is information of sleeve rate. They are not given directly sleeve rate, with the help of this technique they have given. So always remember, a op amp will behave like a low pass. It is not giving band pass response because it's a direct coupled amplifier circuit. Okay. So IC, I by C, I is given 1 milliampere by 5 picofarads. From this you can track the sleeve rate, which is coming to be 0.2 volt per nanosecond. So like this we can finish the sleeve rate. Okay. Sleeve rate. Harinand, very good here. Very good response. Fastly you are giving the answer. 63.6 something you have given. Nice response. Good. So 0.2 volt per nanosecond. That speed is very important for GATE exams. 0.2 volt per nanosecond. Now he has given another information. Output is equal to some 0.5 sin omega t he has given. Your output response for an op amp amplifier is 0.5 sin omega t. If I write sleeve rate again, dV naught divided by dt for maximum value, which is equal to 0.5 omega max. Okay. So 0.5 omega max, cos omega t will become 1 there. So this will be the maximum value. So 0.2 volt per nanosecond, which we got information of sleeve rate, which is 0.5 into 2 pi into f max. Simply find out the f max. Very interesting question again. So most of the times this area they will ask in GATE exams called sleeve rate problems. The f max, if you find out from this, we are getting around 63.6 megahertz. Already some student has given the answer. That's nice to see that answer. Harinath Raju, that's great here. That's great. And other students also given B answer. B is the answer. Most of the students have given great. Datta, Kunwar, Avi Kumar, very good. Narayana, Pandey, Han Basu, super. That's nice to see that answer. B is the perfect answer. So this type of questions, be confident. Okay. Sleeve rate questions we can expect in the GATE exams. So anyway, this is one type of question, you can do it. The next problem we will continue, and everybody know this is a very favorite topic for all the students who are appearing for GATE exam in analog electronics course called Zener diode. It's a compulsory question most of the times I see in GATE exams. It may be electrical or ECE. So I have designed one question. Let us solve this problem, Zener diode problem. For the network of figure, determine the maximum value of Vi. You have to find out the maximum value of Vi. That will maintain VL at 8 volts. It will maintain 8 volts, which is Zener voltage, and not exceed the maximum power rating of the Zener diode. He has given some maximum power rating. You can see PZ max he has given 400 milliwatts. He is telling how much the input maximum we have to keep, such that the output will not change the voltage as 8 volts. I think these questions are very easy to track the problems, because if you want input maximum, I think we need here across the RS, we need current maximum, because when input is maximum, the current passing through RS should be maximum. If this current is maximum, the current passing through Zener diode should be maximum. It's a very simple trick. Okay. If you want this current maximum, first you have to find out this current maximum. That's why he has given some information. First we'll finish that one. First we'll finish IZ max from the given data. It is VZ, it is the PZ max divided by VZ. PZ max he has given is 400 milliwatts divided by 8 volts. This is IZ max. Okay. First we'll finish that value. IZ max value how much? Okay. IZ max we are getting around 50 milliamperes. 50 milliamperes. Then we'll find out this current, which is IS max. If you want to find IS max, it will be equal to IZ max plus IL, because the load should be fixed. So IL is IL only. IZ max plus IL will become the IS max. So IZ max is 50 milliamperes plus IL will become here VZ by 0.22K. So this will become the IS max. So this value we are getting around 86.36 milliamperes. So this is your IS max we are getting. Okay, when you know IS max, if I know IS max is nothing but VA maximum minus VZ divided by RS. This is the formula of IS max. Okay, input maximum minus VZ constant voltage divided by RS will give the IS max. So IS max into RX, first you multiply 6 milliamperes into 91 ohms, okay, plus VZ will come this side. VZ is given 8 volts, which will be equal to VA max. So like this you can solve it. So the answer cannot be 7.85, it is above 8 volts we are getting. So this answer is wrong. First of all, this is wrong answer. It may be 15.85 or 22.35 volts will be the correct answer. But if you solve this answer, you are getting 15.85 volts. So this answer we are expecting for this question. Let me see how many students got this answer. 15.85. Yeah, great. That's great. Yeah, all the students are giving accurate answers. That's great to see your answers. Okay, your study is very perfect. Your practice is wonderful to see all the answers perfectly. So the answer will be B is the correct answer. D is also wrong answer. D is also wrong answer. Perfect. That's great. Okay. So this is one area which you must be strong enough in analog electronics. That is called Zener diode problems. Okay. So let me complete the remaining questions. So one more question is there here. This is the last question. With this we'll end up the session. So the saturated output voltage of the comparator in figure are plus or minus 10 volts he has given. Find Rx such that the frequency of the oscillation is 500 Hz when the potentiometer is connected to the point A. First of all, the student should be conscious with the standard applications which we learned in our op-amps. If you see clearly this circuit, by seeing this only, a student should get a feeling that it's an oscillator. An oscillator never have input on both sides, first point. It's very clear by seeing the problem. Negative side no input, positive side no input, it's an oscillator. And what type of oscillators we have studied is, in multivibrators there is one oscillator called astable multivibrator. Okay, astable multivibrators. Monostable cannot become an oscillator and bistable cannot become an oscillator, but astable can become. And it's one of the important question every year we are getting in GATE exams, maybe for electrical or maybe for EC. Sometimes it miss for electrical, sometimes it will be instrumentation, but compulsory they are touching this area called as astable multivibrator. If you see this question, nothing is there to confuse you. There is a potentiometer connected to R3. There is a potentiometer connected to R3. But this potentiometer, if it is connected to the point A, if the potentiometer is going to the point A, then what is the Rx value in the problem he is asking, such that the frequency of oscillation information he has given. That means a student should not do any derivations in the exams. He must know the formula directly, then only he is perfect to do this question, otherwise he is wasting his time. First of all, the standard knowledge. I will write the standard basics. Astable, first you have to recollect this in the GATE exam. Astable multivibrator. How it looks, first of all I will write side by the diagram. This is minus, this is plus, this is your output V0, and we have Rx, and we have here Cx. This is Cx, and the plus we are connecting with two resistors like this. one is RB and one is RA. So this is exactly the circuit which is a standard model of astable multivibrator. According to this question, if this wiper is connected to this point, the wiper is connected to this point, then automatically according to my formula this becomes RB and these two series resistors will become RA. That R2 will become RB and RA becomes R1 plus R3. So RB becomes R2 here and RA becomes R1 plus R3. This will become 2K, this will become 1K. So what is the standard formula of time period? First I'll write. The time period formula is 2 Rx into Cx, which is a time constant, into ln of 1 plus beta by 1 minus beta. This is the formula. So for a GATE student, you should not do any derivations. Formula should be in your mind. 2 Rx into Cx ln of 1 plus beta by 1 minus beta. What is beta here is fractional beta. Beta is nothing but Ra, this is Ra divided by Ra plus Rb. This is called beta value. Beta is nothing but Ra by Ra plus Rb. So this calculation, if you do it from here, it is coming 2 by 3. It is coming beta value as 2 by 3. So F is equal to frequency of oscillation is 1 by, it is reverse, Rx Cx ln of 1 plus 2 by 3 by 1 minus 2 by 3. If you want Rx to find, 1 by 2 into F into Cx into ln of 5 is coming. So C is given in the problem. The C in the question, C is 0.01 microfarad and F is given 500 hertz, so that we can find out this answer easily. 1 by 2 into 500 hertz into C is 0.01 microfarad into ln of 5. So if you can solve this, we can track the Rx value in the question. So I am expecting most of the students got the answer, Rx value. All the people are giving B as an answer. B as an answer, most of the students are giving B answer. Let me see the answer. 62.1 kilo ohms, perfect. 62.1 kilo ohms, perfect answer. Okay, this answer is perfect. Clear? So I think the time is around 8 o'clock, 8:05, and I have been completed all the problems. So these are the most important areas. Please try to cover in your exams. Okay. At the final stage, don't get tension for going for an exam, because it will disturb your total mind, and whatever the marks you are getting also you will not get. Be cool in life, and whatever you know, you do it perfectly. And I am seeing most of the students are giving perfect answers within a very less time. That accuracy is more enough to get success in the GATE exam. All the best, dear students. Okay, we'll meet again, once again, with your success. Thank you very much. See you. Bye.